Okay, so the basic gist of this question is we've got some sort of ice cream cone that we don't know the exact measurements of, but we know the radius of the sphere at the top, or the hemisphere at the top, is x. We know the height of the ice cream cone is 5x. Then it's melted down and it creates a cylinder, which we know the radius is 10x and the height we're calling h. We've just got to create a formula for h in terms of x. So the first thing I'm going to probably do is work out the individual volumes of the hemisphere and the cone for the first bit. So we're going to start off, I think, with the hemisphere. Now I know the formula for a sphere is 4/3 pi r cubed, but it's a hemisphere, so it's going to be half as big. So I'm just going to halve the 4, so I'm going to make it 2/3 pi, and instead of r, it's going to be x, pi x cubed. Now I can't do anything more than that because I don't know anything more than that. So I'm going to go on to the cone next. Okay, so the volume for a cone is going to be 1/3 pi r squared h. So it's going to be 1/3 pi. Now the radius at the top is x, so it's going to be x squared. And the height, well, the height isn't 5x because obviously there's a hemisphere at the top, but I know the radius of a hemisphere remains constant, so I know that the height of the hemisphere is also going to be x because it's the radius again. So the height of the cone will be 5x take away x, which will be 4x, so times 4x. We can actually cancel this down a little bit, so we go 1/3, it's 4/3 even, because we're timesing the 4, pi x cubed, because the x's times together, and I've times the 4 by the 1/3 to make 4/3. Okay, so we can have the total cone, or total, which is going to be the 2/3 pi x cubed plus the 1/3, 4/3 pi x cubed. So we've got 2/3 of something and we're adding 4/3 of something, so we've got 6/3, which is just 2 pi x cubed. Okay, now we're going to work out the cylinder. So I'm just going to work out the volume for the cylinder. I should really write volume equals in each of these steps, but I knew I'd run out of space if I wrote too much. So in your exam, just write volume equals before each of these phases. So the cylinder, I know that the volume for a cylinder is pi r squared h. Now I know the radius is 10x, so it's going to be pi brackets 10x close brackets squared h, just what it's called. Now what's really important is we realise we're squaring the 10x, we're not just squaring the x and leaving the 10, and that's quite a common mistake. So it's going to be pi times 10 squared is 100, and then x squared is x squared h. So that let's put this all together. So that's 100 pi x squared h. Okay, it says that the metal or whatever it is, modelling clay, is melted down and creates that, which means that the volumes will be equal. So we've got 2 pi x cubed is the volume of the ice cream cone at the top, and that is the same as the 100 pi x squared h. Okay, now we want to make it so that it's h equals. So let's have a think what we can do. Well, I want h on its own, so I want to divide things across really. So let's have a think. Well, pi cancels first of all, so we can get rid of pi. And we can also get rid of x squared. So that'll leave x to the power of 1, which is just x. So I should really show the examiner what I'm doing. So I'm going to divide by pi and divide by x squared both sides. Okay, so that's going to leave us with 2x equals 100h. Now I just need to divide by 100 both sides to get h on its own. So it's going to be 2x over 100 equals h, or h equals, well, it's going to be x over 50.